Good morning, dear students. Welcome to Narayana online classes. Today's our topic is composition of anode rays. Okay. Now, yesterday we discussed about anode rays, discovery of anode rays and characteristics of anode rays we discussed. Today's our topic is composition of anode rays. Okay. Now, here anode rays are positive rays, means they are having a positive charge. And how this positive charge came? By loss of electrons from the gas we are taken inside the discharge tube. Now, if you see the points related to composition of anode rays, the first point, if you see, the electrons constituting the cathode rays must from the atoms of the gas inside the discharge tube. Means whatever the discharge tube we are taking, in the discharge tube the gas, whatever the gas we are taking, by applying high temperature and low pressure conditions, here some invisible rays will be coming from towards cathode as well as anode here. Towards cathode as well as anode here. Means by applying those conditions here, some invisible rays are coming now, those are we are taking as electrons. Okay, means because of the gas inside the discharge tube, that gas here I am taking as A, by applying that low pressure and high temperature conditions, here this gas, okay, it is giving some electrons. Means by loss of the electrons, at the equal amount of positive charge also it should be comes outside from the gas we are taking. Means here, I am repeating once again, the electrons constituting the cathode rays must from the atoms of the gas inside the discharge tube. Inside the discharge tube, here by maintaining low pressure and high temperature conditions, here electrons are coming, and how many electrons are came, those many positive charges will be comes outside from the gas we are taken inside the discharge tube here. And here, if we come to the second point, electrons are negatively charged particles. Yes, these electrons are negatively charged particles. So, the atom must be left with an equivalent amount of positive charge. Equivalent amount of positive charge will be left. Okay, and here these are having positive charge, and these positive charged particles that constitute the anode rays. Means these positive charged particles we are taking as anode rays here. Without gas there is no giving of anode rays as well as cathode rays. Okay. Now here if you come to the third point, electrons have a negative negligible mass. Mass is very less for electrons, and the particles of A plus will have the same mass as A. Means how much amount of mass of A is there, A plus also is having same mass because of the negligible mass of electrons. Electrons mass, how much it is in AMU? It is 0.000548 AMU. That much very less mass. In terms of grams, if you take, it is 9.1 into 10 power minus 31 kilograms you can take. In grams, if you take 9.1 into 10 power minus 28 grams you can take. That much very less mass. Means here mass of electron is negligible. Because of this reason, how much amount of mass of A? Means inside the discharge tube, whatever the gas we are taken, how much mass is there? The same mass will be there for anode rays also. Same mass will be there for anode rays also. Okay. Now here, if we come to the last point in this, so that the value of E by M. What is E by M? E by M is called as what? Charge by mass. Here we are talking about mass. No? How much amount of mass A is there? Same amount of anode rays also is having mass. Now charge by mass ratio will differ from different gases. Means here anode rays will be depending upon what? Inside the gas whatever we are taken. If you are changing the different gases, then automatically anode rays mass also will be changed. Means denominator value will be changed. Then automatically A by M value also will be changed. If denominator value, okay, if more mass is there, then charge by mass ratio value will be less. If mass of the gas, if it is less, E by M value will be more will be there. If you take suppose hydrogen atom, okay, hydrogen atom, if you take mass of hydrogen atom is very less, then E by M value will be very high. Means mass of the gas inside the discharge tube, whatever you are taking, if it is having more mass, then specific charge E by M value will be very less. Now here, if you see the fourth point, the value of E by M will be differ from different gases, gas to gas, and smaller the mass of the gas, smaller the mass of the gas inside the discharge tube, then higher the E by M value. Higher the E by M value. Then automatically charge by mass ratio value will be here higher when if denominator value is less. When the denominator value will be less, in the discharge tube experiment, if you are using less mass gas particle if you take, like hydrogen gas if you take. Okay, suppose if you are using any highest mass gas particle if you take, then automatically denominator value will be, it is high, then charge by mass ratio value will be very less. Okay, and generally charge by mass ratio value will be according to the gas we are taken. Okay, right? Thank you.